What's up, everybody? Welcome back to another weekly live stream from Scalar Learning. And normally we do the live streams every Wednesday, so this is a little different. We're doing it on a Saturday. And there's a reason why. The reason why is because I just moved, and now I've got a new location, a new little setup that's going to be even sweeter in about a week when I get everything set up. It's going to mark the beginning of a whole new era in my YouTube presence and the types of things I'm going to be providing you guys and the amount of content that's going to be coming. But all that, the entire grand plan will be announced shortly. Right now, we are just sticking with our weekly live stream relating to the Khan Academy math practice problems. So without further ado, let's jump into it. And today we are going over linear equation word problems level 3. All right, so let's do it here. Now, question number 1. As always, I'm doing these problems for the first time, ideally, unless sometimes I may see a repeat. But usually I'm not looking at these. I'm doing them for the first time so that it's an authentic, real experience. You're seeing how I'm thinking and reacting in real time. And that's part of the fun. Sometimes, you never know what you're going to get and you never know what you're going to see. And I'm not immune, so I'm not perfect. So not everything's going to be perfect, but I try to do my best. And hopefully you guys can learn along the way. So let's jump into problem number 1, linear equation word problems. The maximum activity level of a particular enzyme is 60 micromolars per minute. Now you see already, this is going to be look at all these symbols, and I can see the language is relatively dense. We're already talking about enzymes, micromolars, which is some sort of a rate, micromolars per minute. And I've never heard of that term before, micromolars. It's probably some really small measurement, but it doesn't matter. We're going to try and sift through all the technical jargon to get to the heart of what's being asked. So this maximum activity level occurs at 20 degrees Celsius. So I'm just going to kind of write down some of these numbers. And then for every 2 degrees above or below 20, so plus or minus 2, the enzyme decreases by 8. Whatever that is. Probably don't need to write all this down, but it decreases by that per minute. Which of the following equations can be used to find the temperature T at which the enzyme activity level is 40? Now, there's going to be 2 places where the activity level will be 40, okay? Because this, we're dropping by 8 degrees every time this 8 whatever this is unit per minute every time it changes beyond 20. So there's going to be 2 places, right? And I'm going to show you how we're going to reach that, and then we'll use that to figure out this inequality. So if I go from 20, if I go to 22, okay, 2 plus 2, if I change it by 2 degrees, remember we're going to be decreasing by 8. So it's starting at 60. So we're decreasing by 8. And we're dropping to 52, right? For every 2 degrees above or below, it decreases by 8. So we're at 60, we're going to 8. Then at 24, we're going to 44, right? We're dropping by 8 again. And then I'm assuming that since every 2 we're dropping by 8, every 1 we're dropping by 4. And so that means at 25 degrees, we're at 40. The other way this will go is if we're at 20 and we drop to 18, same thing, it's still going to drop by 8. That's what I said, whether it goes up or down, it drops by 8. So then we're at 52. At 16, same thing, we're at 44. And then at 15, we are at 40. So these are the 2 points where when we hit these different temperatures, we're going to equal 40. All right, now let's figure out how that equates. Now, one way we can figure this out is we can be like, okay, well, for which of these values when I plug in, let's say this is my temperature, when I plug in 25, do I get 40? And also I have to plug in 15 and get 40. That's one way. First, I'm just going to kind of look at these formulas and say which one makes sense. So we're all seeing that in the absolute value, we're taking a difference of the temperature in 20. And again, every time it's changing by not 1 degree, but 2 degrees, we're getting a change of 8. But we already figured out that means when it changes by 1 degree, we're getting a change of 1 degree, we're getting a change of the 4 micromolars, right? That's what we figured out from here to here, 24 to 25, change of 1, and we're seeing a change of just 4 degrees. So I know that the change is actually going to be not multiply every degree change. It's not going to be multiplied by 8. It's going to be multiplied by 4. So I can already eliminate D and B. And now we're down to A or C. So the question is, every time the temperature changes 1 degree, are we removing 4 degrees or are we adding 4 degrees? That's the difference between these two. This is subtracting, this is adding. And we're definitely subtracting, as we said, the temperature's dropping, so it's got to be A. But now once I figure that out, I want to plug in my values and make sure what I deduced is actually correct. So if I plug in 25 here, I get 25 minus 20, which is 5. 5 times 4 is 20. 60 minus 20, 40. Boom, that works. And what about if I plug in 15? 15 minus 20 is negative 5. Absolute value of that is 5. 5 times 4 is 20. 60 minus 20 is 40. So this should be pretty rock solid, and it's good. Okay. Next, Uch is a cartographer. He picks a scale to fit a map of India onto a page of an atlas. The page is 12 by 12, so it's a square, with 0.75 inches margins on all 4 sides. So it's something like this. And these margins are 0.75 inches. India measures this many kilometers from north to south and this many kilometers from east to west. So let's say, I'm just going to draw it out here, north to south and then east to west. Uch wants the longest dimension of India, which is this north to south, to fit exactly between the margins of the page. So to fit in this distance. So this distance needs to hold that 3214. Okay. If K is the number of kilometers per inch, which equation best models the situation? So this is a lot. This is a pretty hard question, I'd say. And let's first figure out what is the distance that we actually have to work with. Since it's 12 by 12, so it's 12 up and down, but remember we have to take into account that this margin, and since I've drawn it, this is going to be pretty clear that I don't just take 0.75, I take 0.75 from both up, top and bottom. So I'm really taking off 1.5. So 12 minus 1.5 is 10.5. So I got 10.5 inches to play with. Okay, so now we know that 3214 divided by some scale factor, and I guess they're calling that K. K is the number of kilometers per inch. Oh wait, there's another way we can do this. We can say, let me make this easier. 3214 kilometers per 10.5 inches equals K. Actually, that's even easier. Okay, so this is it. This is kilometers per inches of room. And now we can kind of go and see which one of these fits. We don't have that exactly, but it looks like we have some different manipulations of this equation. And so first, I see A and B that I can eliminate, and I'm going to show you why in a second. Remember, we got 10.5 inches to work with, not 12. These guys use 12, so A and B are out. Now we have C and D that are probably, one of those is correct. So let's figure out, we got this equation, it's not exactly the same, but look at this one. It's got 10.5 times K. Well, I can get that pretty easily if I multiply both sides by 10.5, okay, and we have that equation. It's just the numbers are flipped, but that, of course, doesn't matter. So it's probably got to be this, but let me show you why this isn't correct. So if we reset back to my original equation, there's no way I can get K over 10.5. I can multiply both sides by 10.5 like I did, but I'm never going to get K over 10.5. It's not going to happen. I could get K over 3214 equals 1 over 10.5, but with our typical variable isolation tactics, we're not going to do any better. This is just not the same equation. All right, next. Alma and Erica work part-time stocking shelves at a grocery store. It's 7 on Saturday. Okay. Alma begins unpacking at a rate of 1 box per 6 minutes. Erica joins her at 7:45 and unpacks 1 box every 6 minutes. I'm sorry, every 5 minutes, excuse me. When finished with this task, a total of 24 boxes have been unpacked since 7 a.m. If X represents the number of minutes for which Alma has been working, which one's Alma? Alma's this one. And Erica. If X represents the number of minutes for which, oh wait, hold on, when finished, 24 boxes have been unpacked. If X represents the number of minutes for which Alma has been working, which of the following equations best models the situation? So I can already tell, this one's looking pretty good from the get-go. Hold on. Yeah, because X is in minutes. Wait, did it say X is hours or minutes? Yeah, it's minutes. The only thing is... Yeah, it is in minutes. Okay, the rate's in minutes. Sorry. I thought the rate was in hours, and that's what threw me for a loop for a second. I feel like A is probably pretty good, but let's, I'm going to tag it, and I'll explain why in a second. Let me just look at these other ones. This one is in hours, okay? 45 minutes, they're subtracting 3/4 from 1 hour, essentially. But it's not in hours. It's saying X represents the number of minutes. So these would be correct if we're talking about hours. So I'm looking at either C or A. The problem with this is that I can already see that they're trying to represent the number of boxes that Alma unpacks as 6X, which doesn't make sense because if we plug in 1 minute, 1 for X, she unpacks 6 boxes. 2, she unpacks 12. That's 6 boxes per minute, not 1 box per 6 minutes. So this is our rate. It should be 1/6 times X, which is the number of boxes she'll unpack, plus 1/5 times, again, X is when Alma started. Erica is 45 minutes after, so 45 minutes less. So this looks like our winner right here. Okay, let's see. Yeah, and it's correct. On a highway, drivers are required to maintain a speed of between 55 and 65 miles per hour. A $7 penalty is assessed for each 1 mile per hour. A driver's speed is outside of this range. If a driver receives $42 penalty, what are the possible values? Okay, so $42, it's $7 per mile, right? So 14 for 2, 21 for 3, so on and so forth, right? So we're talking about a $42 penalty, which would be double 3, which would mean it's 6 miles either below or above this target range here. So 6 miles above would put it at 71. 6 miles below would put it at 49. So they're either going 49 or 71 miles per hour, which is B. I mean, this one is just pretty straightforward. You could come up with you could probably come up with an equation. You don't really need to. I think this cuts straight to the point, and that's that. Question number 5. On January 1st, 2014, approximately 450,000 buildings in the United States had solar panels. This number increased by a total of about 180,000 over the next 12 months. Assuming a constant rate of change, let's say 12 months. How many months after January 1st would 900,000 buildings have solar panels, excuse me. So let's say 450 is my starting point. Plus, now this is 180 per 12 months. We want the monthly rate because they're asking how many months. So if it's 180 per 12 months, and this is a calculator problem, but we can do it probably without a calculator. This is 10, this is 50, this equals 15. If you want to do the math really quickly, it's 1, 12, 6, 0, and then 5. So it's 15. So we know it's 450 plus 15 solar panels per month, X. And we want to know when this equals 900,000, or 900 in this sense. We're doing these all in hundreds of thousands, in thousands. So that's 15,000, 450,000, 900,000. And now what we got to do is solve for this equation. So let's subtract 450 from both sides. And we get 15x equals 450. Divide by 15, divide by 15. And they get x equals 30. So 30 months, and it will have a total of 900,000. Yeah, so I think this is, I'm just making sure I'm not misreading anything. It wasn't what I would have expected. The other problems seemed a lot harder. So sometimes I just want to rethink and make sure I understood it correctly. And I think so. Okay. All right, that is it for the live stream from Scalar Learning this week. Again, sorry it was late. I moved, had no internet for until Friday, actually until yesterday. So I hope you found that helpful. If you did, make sure to click the like button. If you want to see more from Scalar Learning, make sure to click the subscribe button. We got a new SAT coming up on October 6th, and guess what? We're not only going to be talking about it, I'm not only going to be doing an entire session of material the week leading up to it, but I will be taking the October SAT myself, which I'm very excited about. Haven't taken an SAT in almost 2 years. So that's it. If you have any questions, leave questions in the comment section below. I answer every question that comes my way. Thank you guys so much, and I'll see you guys next time. Take it easy.